Yeah, hi. In this video, I'm going to explain an action potential. But before that, I will give an analogy. An action potential is actually a force that an excitatory cell, e.g., a neuron cell or muscle cell, needs to perform an action. For example, if you touch a very hot kettle, you feel the hot sensation, and you move your hand away right away. So that hot sensation is a stimulus that triggers a process of reaction, which leads to an action potential. So to have a better understanding of an action potential of a neuron, it has to be an excitatory cell. We need to know what the cell is doing at rest. That leads us to resting membrane potential of a neuron, of a cell, of the cell membrane, the neuron cell. So inside our cell, we have more potassium ion than outside. And we have more sodium ions outside than inside. But around the cell membrane, of the axon, potassium ion has a leak gate. So that allows potassium ion to flow out of the cell. And that's through diffusion. Then that action makes inside of our cell to have more negatively charged ions than outside of the cell. So the difference in the gradient make the inside of the cell, to have about negative 70 millivolts compared to outside. So that is our resting membrane potential. Now let's talk about action potential itself, of a neuron itself. So remember the stimulus I told you about, that hot sensation. So that's a signal. So that signal triggers a chemical, a neurotransmitter in form of glutamate. So that attaches to the ligand channel on the axon, on the membrane, around the axon. So when that happens, it causes the ligand channel to open. As that opens, sodium ion they begin to rush in. So they rush in from the area of high concentration to the area of low concentration because they are more on the outside. So the gradient concentration inside the cell now begin to change from negative to positive. As that happens, the action, it triggers and triggers. More sodium will be coming in, it will be coming in. Then the resting membrane potential of negative 70 will now, shoot up to around negative 55 because the inside of the cell is becoming positive. So to shoot up, so that is called, and that is our very threshold, So that is called like a kind of depolarization. Is moving up. So as that happens, so that will now cause the sodium voltage gated channel also to open. It will trigger them to open. Then more sodium will begin to rush in and rushing and rushing into the cell. Then the cell becomes so depolarized to about positive 30 millivolts. That's when we get the overshoot. As that happens, when we get that overshoot, the sodium gated channel will shut down, and that will open the potassium gated channel. As that open, potassium now will begin to rush out of the cell. They begin to move out, and and we now have a repolarization. So as that happens, so the inside now try to become now back to the negative gradient. Then it will keep going down and reach about negative 90, which is called the hyperpolarization. And when that happened, so that's when the sodium potassium pump will now come to help. As that comes in, it will now push back out 3 sodium ion and push in 2 potassium ion, and that will help to bring the cell back to its resting membrane potential of negative 70. I hope you understand. Okay, bye.